Today I'm going to talk about 8.3, and it's another factoring technique. And we'll use this when factoring by GCF doesn't work and when factoring by grouping doesn't work. As you can see with this expression here, we cannot pull out any common factors between all three, so GCF won't work. And we don't even have enough terms here to factor by grouping, so we can't do that. And the word quadratic, at least at this point for us, all you need to know is that quadratic means the highest degree or the highest exponent of the expression is 2. So it's squared. And quadratics usually come down to 3 terms. So, or at least 3 in the end after doing some combining and things like that. So before we talk about factoring a quadratic, I want to review something that we've done in the past here, which is FOIL. So remember we did our first, so we'd go x squared, and then our outsides we'd times, and then insides, and then last. Okay? And what we would find is that those two middle terms could be combined and added together. So we get x squared here minus 1x minus 6 to get a final answer. So basically what we're going to do today is take the answer and turn it back into its factors, essentially. So today you can think of it as the reverse FOIL method. And I'll show you some different techniques in class, but to save some time on the video, I'm only going to go one route. But basically, here's what we need to know. Our first two spots have to give us x to the second. So x and x. And everything here is positive, which is good to know because everything inside of our parentheses will then be positive. So the only thing left that we have to figure out is we know that our last two numbers have to give us 18 when we multiply them together, but as we just saw and reviewed, those two factors also have to add to give us 9. So we need to look at different factors of 18 and figure out which ones are going to be which pair we're going to use. So factors of 18, 1 and 18, 2 and 9, 3 and 6. We're looking for the pair that when we add them together we get 9, so we're going to use these two. And in this situation it doesn't matter where we put the 3 and the 6, so it could be either, but this would be our factored answer. And if you ever wanted to check that, you could FOIL this, and what you should find out is we get that. 3 times 6 does give us the 18, and then 6x plus 3x gives us the 9x, and we already know that x times x gives us the x squared. So just a quick way to check that. But anyway, our final answer is now what I had circled before, before I erased everything. Okay. So like I said, there's a table method I can show you in class as well that some of you may like. But basically what we're doing here is playing the game of, okay, we know our first two terms have to give us x squared, which is x times x. And then we're looking for two numbers that we can multiply to get negative 40 that add to give me negative 3. Okay, now we have some negative stuff going on. And here's where we need to use our knowledge of multiplication with negatives and positives. I know one of these is going to have to be negative and one's going to have to be positive because a negative times a positive will give me a negative. One other thing to note is when we're looking at different factors of 40, one of them we're going to have those add together to give me a negative number. So the bigger number has to be negative. So let's take a look. So looking at 40, we need two factors of 40 that are 3 units apart. So 8 and 5. And as I had just mentioned, one of them is going to have to be negative, one's going to have to be positive. In order to figure out which one, we need to know that, okay, they need to add together to give me a negative, which tells me that we need to use negative 8. Okay, so 8's going to have to go here, and 5 is going to have to go here. And again, you can FOIL this out to see that it comes out to the correct answer. All right, number 3. This one's a little bit different. Again, our first two spots have to be x and x because x times x will give me x squared. -6. This one's a little interesting. So we know that we have to get a negative. So remember, again, it's going to have to be plus minus or minus plus. It doesn't matter where we put it. We just know that a positive times a negative is going to give me a negative. So looking at -6, we got to look at some different factors here. We could use 2 and 3. Now 2 plus 3 does give me 5, but -2 plus 3 is not going to work, nor will -3 plus 2 work. So we got to look to something else. So 6 and 1. So don't forget that two factors of a number could be 1 in itself as well. We need them to add to give me a positive, which tells me that the 1 is going to have to be negative. So the 6 will go here, and the 1 will go here. And there we are. Okay. So a little bit tricky with that one, but make sure you consider all factors. And sometimes you'll just have to do a little guess and check with it to see if it works. Last example. This one is a little bit different as well. So I'm pretty much showing you each type that you could run into. Again, our first two terms have to multiply to give me x squared, so x times x will do that. Notice here that we get a positive from multiplying our last terms, but we have to add to get a negative number. Well, here's where we have to use our knowledge of a negative times a negative will give me a positive, and when I add two negatives together, I also get a negative for the middle. So 16, I know both of these are going to have to be negative, so let's just look at some options. So -4 times -4, yes, that is 16. However, -4 plus -4 is not -10. So let's look at -2 and -8. -2 times -8 is positive 16, and -2 plus -8 gives me -10, so we have found our answer. And again, we could have put the 2 or the 8 in either spot. Okay, so like I said, I will show you some different options in class on how we can do that, but essentially it's all the same thing. We're just looking for unfoiling, essentially. All right.